In this short lecture, we'll be looking into the traffic characteristics, the requirements, and the switching modes of a switch. There are some important characteristics and requirements that we have to consider regarding traffic. Transmission unit length, the variability of data flow, the spatial distribution, the symmetry of data flow, the data rate and reliability, and security and privacy. A transmission unit, it can be a packet, a frame, slat, time, cell, or segment. There are two types of transmission unit lengths. The first one is fixed length, the next is variable length. Fixed length, they're simple, they're more secure, and they're faster to process. The variable length, they're more flexible for video and voice transfer and they're used in external line interfaces. Spatial distribution is how much space is allocated in the channel for different types of traffic. The first one is 18-20 rule. 80% is allocated to inter-subnetwork traffic and 20% is allocated to inter-subnetwork traffic. The reason behind is to confine the traffic within the layer 2, that is the switches. And nowadays it's become obsolete with the virtual circuits. Bursty traffic. It means inconsistent traffic rate. And there are different types of usages among different users. And switching helps users to use the idle time for the users in the same channel. And burstiness can be improved by buffering and caching. Packet switching versus circuit switching. Both have their own pros and cons. For example, packet switching, the discrete units of information on a shared medium. The header will wait to send the packets. Circuit switching, the decisions are predetermined, and the connections, they exist until the transfer is complete, so it's totally dedicated. In packet versus circuit switching, packet has an efficient link usage because it shares the same link. Not to mention, packet switching is also robust. In circuit switching, it guarantees the service, but it has an inefficient link usage. And finally, it all comes down to the requirements. The best way to send a packet is source routing. Source routing is where the sender of the packet, he can partially or completely specify the route the packet can take through a network. That is, he can specify the final destination address or the intermediate address. Why source routing? Because it's easy to troubleshoot. It has improved trace route because the destination is given by the source itself. And it also enables a node to discover all the possible routes to a host. Source routing also has its own disadvantages. It can't reroute a packet after it has been launched since it comes with a source address, and it has no control over the network performance. So if there's network congestion, there's nothing you can do about it. And it requires a large packet headers, and it's also easier to be attacked. The present scenario is totally different. Nowadays they employ more of hybrid networks. They combine the advantages of both circuit switching and packet switching, and they created another new network type, which is a virtual circuit. A virtual circuit is good to work with. Virtual circuits are just like circuit switch networks, except that they're not actually circuits. What they actually is used to transport data over a packet switched computer network. It will appear as though there is a dedicated physical layer link between the source and the destination, but they are not a physical layer. In virtual circuits, headers, they don't identify the destination, but a flow or a connection. That is, they will say which node the packet is to be forwarded, and we can expect the data to be delivered in the correct order. And also that signaling overhead is required during connection establishment phase. Multi-protocol label switching is a network protocol which occurs in between data link layer and the network layer. So basically the network packets are transferred in the data link layer rather than in the network layer. So that accounts for a better transport efficiency. Asynchronous transfer mode is one of the most widely used network protocols nowadays. It uses time duration multiplexing to encode data into small fixed size cells. And these cells, since they're fixed in size, they are very fast to be switched. And faster the switching, better. Thanks for your time. Hope it was useful.
Created using Powtoon.